how do we graph this? Here's the algorithm. First, you let the inequality becomes the equation, right? You let it be equal to the right hand side, and then you construct the line. You know how to do that. Either you do rise of a run, or you pick just point for x and y. You need 2 points to graph a line, and then the next step will be, if the original inequality is include the equal side, like say less than or equal to or greater than or equal to, then your line will be solid, right? If it's strictly less than or strictly greater than, your line is dashed. And then to pick the region solution, you pick a point. Pick a point. If the point you pick when you plug it into the original inequality is true, then you shade that region where you pick the point. If it falls, we shade the opposite. Right? That's it. So here we did last time, we did these two. Pretty simple. Let's do this one. Here it's just a single inequality. Here we have a pair. It's the same thing, right? The solution of the pairs will be where they overlapping. So let's graph this. I'll highlight this in blue. So the first step, you let x minus y equal 3. And then you pick point. Usually I just do 0, 0 for x-intercept and y-intercept. So x and y. I'm going to let x equal 0, and then I'm going to let y equal 0. When x equals 0, what's y equal? -3, right? And when y is 0, x is 3. Right? So 0, -3, and 3, 0. You got 2 points. Just connect them to the line. Dash or solid? On the exam, be careful. It's just very easy to forget. You know, just remember it has to be dash or solid. And then you pick a test point. My favorite, if the line does not go through the origin, pick 0, 0. Zero, 0 right there. Sorry, can you guys see? You plug into where? Where do I plug in? The very first, right? The very first. So 0 minus 0 greater than 3. Is 0 greater than 3? No, right? It's false. So you shade the opposite. Why don't you guys do the second one? We have a highlight in red. Do the second one for me. I'll walk around, see how you do. I was soft and what? Sorry. It looks like that. No, it was really on the line. That's yeah. I think you just drive it. No, I drive this one. I cannot afford it. I'm All right. So for the second inequality, I'm gonna let it equal. I'm gonna solve for y. So I'll divide both sides by 5. You don't have to. I just gonna use rise over run, so I'm gonna solve for y. So y equal negative 1/5 x plus 4. What is my y-intercept? What, right? Is y equal mx plus b, right? So that's the y-intercept. So I'm gonna start at 4. So at 4 here, y-intercept right here, 0, 4. Rise over run. How many units do I rise? Yeah, that one, right, 5, right? You rise down because it's negative slope. So down 1 and then go to the right 5 unit. Right there, that's my second point. The red one first. And then you can grab. Or you can pick point like I did in the first one. Doesn't matter. Solid or dot? So less than or equal to something? Solid. Pick a test point again. It'll be 0, 0 again because it does not go through 0, 0. What do you think? When I plug into the original, 0 less than 20, is it true or false? True, right? True. So 0 less than 20, less than or equal to 20. So you say it's true. So where do I shade? Below the red, right? Below. Which just makes sense. Here you can see clearly. If you solve for y, don't write this down. Y is less than or equal to negative 1/5 x plus 4. So it's gonna be below. It's only true if you solve for y, right? If you don't solve for y like the one in blue, here it looks like I should have shaded this way, right? But I don't, because if you solve for y, what happens? Subtract x, so negative y greater than negative x plus 3, divide both sides by negative 1, you flip the sign, right? So y is less than instead of greater than. So you shade the region below. So it's only true if you solve for y. If you try to guess and check that kind of method, without going to pick test point, just can't get wrong with that. Just be sure. Yes. Oh, I plug it in. So this is your x, this is your y. And I plug it in. 5 times 0 is 0. Negative 0 plus 20 is 20. You don't have to pick 0 if you don't like. You can pick something else, say negative 5, 0. Yeah, and then you plug it in. Okay. And as long as the line does not go through the origin, then you can pick 0, 0. All right. I know you're anxious about the quiz, but this is on your exam too. And remind you, exam is much, much more important than the quiz. Right? You cannot take in any quizzes and you only lose how many? 35 points. And you don't take one exam, you lose 100 points. Right? So exam is really, really, really important. And something like this almost will be on your exam. Now, finally, I want you to indicate the solution. So what is my solution? On the exam, I'll make that 1 point. You gotta indicate solution. The solution will be where the intersect, right? Which is right here in the diamond shape region. So you gotta do that. That's 1 point. So far, so good. All right. Number 2 here is pretty much the same. At least if we look at the last 2 inequality. Now the first 2, what does that mean? They restricted your domain into what? What quadrant that be? What quadrant you have x is y is positive? Huh? The second one have negative x. Yeah, the first one, right? So this implied the first one. This implied they restrict the first one. And then you graph the same thing. Do the same thing for your graph. I'll write it below here. So let me highlight stuff again. That's blue. That's red. So x my plus 6. I'm sorry, x plus y minus 6. 0. Say y equal negative x plus 6. All right, here is m is negative 1 over 1, right? Your slope is 6. I'm sorry, your y-intercept is 6. So right here, that's not negative. When I screenshot it, it's just part of. I screenshot the first quadrant, so it extended to be the second quadrant, but that's not negative. Okay? It's positive 6. And then rise, how many unit rise? Rise down 1, right? Rise down 1. So down 1, right 2. I'm sorry, right 1. Dash or solid? Solid. They both solid. All right. I don't bother to stretch my graph into other quadrants. We're not gonna use it. All right, the second one. Oh, pick point first. I forgot. Test point. 0, 0 again. By the way, it's not always 0, 0, okay? It's just because my line is now passing through origin, I'm allowed to pick 0, 0. You plug back into the original. So x plus y minus 6 is less than or equal to 0. That's the original. That's the original. Is negative 6 less than or equal to 0? True or false? True, right? True. I'm sure you know. It's just somehow your brain just freeze for a moment. It's true. Some people argue maybe it's not equal to, so it's technically false. But we're doing what? Either or, right? So what true is true. Okay. All right. The second one. Oh, which one I shade? So I shade. It's true. So I shade. Yes. Yes. Oh, did I? Oh, okay. My bad. I was using that little grid. Sorry. Thank you. That should be. Should I go down more, right? Like that. All right. Thank you. I was using the grid. Okay, like that. All right. Thank you very much. Right, you gotta do the second one. 2x plus y minus 8. Bless you. All right, you gotta do that one. You know, let's, you know what? Let me pick something else. I changed my mind. I'm gonna pick 2, 2. Instead of 0, 0, see what happened. When you plug it in, what do you see? 2 plus 2 minus 6 is still -2, which is still less than or equal to 0, right? Still true. Yeah, let's pick something just for the change. I always pick 0, 0. Anyone have the red one? The red one? Huh? It's false? It's false. Um, so, so let's graph this. So y equal -2x plus 8. We do rise over runs again. M is -2/1. -2/1. So go down 2. Well, from 8. You go down 2. And then you go to the right one. They're both solid, so we okay. You can pick something else. You don't want to pick 2, 2. Say I'll pick run out color here. I'll pick I'll pick 1, 4. How's that? It's kind of close to the red. Sorry. Yeah, make it in like salmon color. There you go. 1, 4. When you plug it into the original, what do you see? 2 times 1 is 1, 2. Plus 4 is 6. 6 minus 8 is -2. -2 is still less than or equal to 0. It's true. Oh. Oh. I was looking at the less equal to greater sign. Oh, okay. Yeah. Solution is this, right? It's this one. Let me highlight the solution in purple. That is the solution. Do you have any question for this one? Let me see what we have. This one, we're gonna construct it, but we're gonna use Desmos to graph, okay? So it's gonna be the same. Concert attendance. Is anyone have attend a concert before? What concert you went to?
I've been to Morgan Wallen, Drake 2 times,
Yeah.
Justin Bieber. I like a lot of concerts.
Good for you. Yeah, good for you. Back then when I was an undergrad, I went to Usher once because my boyfriend husband now at the time like Usher, but I didn't care much for it. Yeah, but it's just fun, undergrad things. Peninsula Brass Band. I have no idea what it is. Anyone know what it is? Will hold a semi-annual concert in the community center that has seating capacity of 500 seats. The band expects that at least 200 season ticket holders will attend the concert, and at least 100 non-season ticket holders will also attend the concert. I want you to write the equation that gives the restriction on the number of each type of ticket held at the concert. So, well, you're gonna define your variable first, right? So I'm gonna let x, y be what? Number of ticket holder for season and non-season respectively. Why don't you help me construct that one? I'll give you a few seconds. Bless you. Bless you again. All right, someone come up with an inequality yet? Let me know what you got. Should be easy. Just use, how about this? Don't think about math. Just think about logic. In practical sense, common sense. You got 500 ticket total. You cannot sell more than what 500 can hear you, right? So just think logically. You don't have to think about math. So tell me in word, what does it mean, 500 ticket? Are you shy? Huh? Just tell me in words. That mean the number of ticket of season ticket holder and non-season ticket holder had to be what? Yeah, had be at most 500, right? So something like this. And we gotta figure it out mathematically what the left-hand side is, which is what? Better than that. All right, so x plus y. You're right, x plus y. So it's the first one. There's 3 of them actually. Yeah, the 3 of them. What the other 2? What the other 2? Yeah, there's a restriction. So x has to be what? Yeah, at least so greater equal to 200, and y is at least 100. Let's do, should I do by hand? Let's do this by hand. Let's do this by hand just because the restriction a little bit different. Let me write things down here. X is greater than 200. I'm gonna have to do some tick mark here. So 100, 200, 300, 400, 500. 100, 200, 300, 400, 500. X has to be greater or equal to 200. So what does that mean? What kind of lie should I have? What kind of lie should I have? I know, but in terms of shape, direction wise. Let me highlight what I'm asking you. Very good, right? Vertical line. So solid, right? They all solid. What about Y? Yeah, what was that? Oh God, I wish I should have. All right. Now, what do I shade? Let's do the blue line first. Should I shade here or here? Right or left? Right or left? So don't worry about the red one. Just talk about the two. Right. Greater than bigger than 200. So anything that larger than 200. So shade to the right. Okay. You don't please don't shade it. No, don't shade it. I just shade for now. What about the red one? Top, right? So what's the intersection? This, right? So let me erase that. Don't shade it. So basically, I don't need that. I don't need that. All I need is this one. All right, now you grab x plus y. Let x equal 0, y is 500. I'll use black. If y equals 0, x is 500 right there. You graph it. I don't need that. I don't need all the outside. I just need this. Maybe I'll do a very light shade of gray outside. Pick a test point. Your best point would be what? 300 and 200, right? Well, let's pick 105, 105 and 205. Is that okay? Or 2010, whatever. Say here. Right here. What is that? Doesn't have to be exact. Just say here is 250, 230, comma 150 maybe. If you don't know, let's do this. If I pick x to be 230, then what's y has to be? 500 minus 230 is 270. No, it doesn't write. Something wrong. Something wrong. Hey, hang on. Something wrong. Give me a second. Something wrong. I think it's okay for me to pick this one. That's fine. Yeah. 200 and 300. Yeah, I can do that. When you plug it in, what happened? 200 plus 300, is it less than or equal to 500? Yes, right? Yes. So you shade that region. So right there, that's your solution. It's not the best point because on the line, maybe you pick something different. Maybe 200 and 290. You can pick 200 and 290. Let me show you how it looked like on decimal. X is very equal to 200. All right, guys, if you don't talk about math, just don't talk at all. Because I'm getting up here. I'm very easygoing, but I'm not easy being pushed over. Greater equal to 100. X plus y. X plus y is less than or equal to 500. Let me do like this. I'm gonna pick just one color, say red. There you go. So the darkest shade will be your solution. You can check your decimals. Assume the attendance will be as expected. Is it possible for season ticket holder and non-season ticket holders to attend the concert? Attendance will be expected. Yes, right? Yes, right? Yeah, because 200 and 100 added up is only 300. Right, so yes. And it's still less than or equal to 500. All right, last one, and we take a quiz. Last one, we take a quiz. This will be quick. I need your help with this one. Given the graph and given the equation, can you fill in the inequalities? All right, first of all, let's do the easy one first. Those two. I fill those two in. Yeah. So the first quadrant, so be greater equal to 0. Which one is which? Which is which? You don't have to use calculator to figure it out. One, they have a negative slope. They both negative. And they both negative. Yeah, but one is steeper. Yeah, so the first one, right? So this if I divide both side by 2/5, and then this one will be what? 1/3. Now let's do y-intercept. Let's do y-x-intercept. If x equals 0, y is 6. If y equals 0, x is 18. 18. So it's gotta be this one, right? Or this one. Greater than or less than? I'm gonna solve. I'm gonna solve for y first. $18 divided by 3 is 6. So it's gonna be less than, right? It's gonna be less than. What about the top one? I don't have to solve for y. How about this? Let's pick a test point. That's our favorite. Let's pick a test point. Let's pick a test point. Let's pick zeros. Let's pick I don't want zeros. Let's pick 2, 0. 2, 0. So 2 plus 0 is 2 is less than or equal to 18. So yes, the test point. And then you pick another point, say 10 plus 4 is 14, is still less than 30. So yes. Yay. That's good. Yay, we're done. 6.1. Now we can talk.